Hello everyone, good morning.
Good morning, sir.
Okay, so today we have open session for week 10. Did any of you covered week 10? I know.
Not yet, sir.
Okay, so we can, I think, make it week 1 to 9 all the doubts if anyone has. Okay.
Sir, will week 10 assignment due date be postponed or it will remain the same?
For now, it's the same, but it may postpone. There's not surety, but there are chances.
Actually, now then we're not able to focus on the revision part of it because then we're focusing on finishing week 10.
Yeah, generally we don't have a grade assignment deadline the week of quiz.
Yes.
Yeah, so most probably it should, but for now it's only 9th March.
Okay.
Did anyone of you even started week 10 or not?
I've done halfway the videos.
Okay.
A little bit, sir, not much more.
Okay, so if nobody has doubt in week 10, I think we can make it.
Sir, activity question 10.3, question number 4, if you could explain.
Okay. Yeah, so I was saying after, I think there are very few doubts for week 10. So we can make a doubt session for week 1 to 8 as well, if you guys have any.
Sir, can you give a brief can we have a brief discussion about what content is all covered in week 10, so if deadline is not extended, we would be able to at least understand every content faster.
See, going through ma'am's video is the best way to ever see. After you have seen the lecture, then I give a brief description. That would be helpful. If you haven't seen the lecture and then if I will be giving the description, it won't be that much helpful for you.
Actually, there is nothing much to explain in this video.
Yeah, these are just
less
properties.
only. Video content is somewhat lengthy, but topic is less only.
Yeah, week 9 and 10 are very light weeks. Okay, this question I think Ravikant was asking, right?
Yes, sir.
There are 1,000 mobile phones. Okay. Okay. So out of 1,000, we know that 100 are defective. Okay. And 20 mobiles a retailer buys at price of this. Okay. And 10,000 if for example. Okay. Okay. So see, what you can do is this. I have 20 phones, right? And like phone 1, phone 2, phone 3, so on up to phone 19 and phone 20, right? So I can assign random variable to each of the phone. Let's say that x1 be the random variable at my first. It will take. We should do it. In general, we can define xi. Right? I will have the profit of 2,500, right? If it is not defective. And I will face a loss of I think 10,000 rupees, right? If it is defective. So I have to find my expected gain or loss, whatever I'm having. So I goes from 1 to so on up to 20, right? Is it clear till this step?
Yes, sir, it's clear.
Okay. So the expected value for my any ith device, whether it's defective or not. So I will get 2,500 times the probability of it not being defective, right?
Yes, sir,
And I
correct.
will lose 10,000 if it is defective. So probability of out of 1,000, 100 are defective, right?
Yes, sir.
So it would be so not defective. It's something 9,900 out of sorry, 900 out of 1,000, and it would be 1,000 times there are 100 defective out of total 1,000, right? Is that how you approach?
I have tried different ways, but I could not get the answer.
Okay. Okay. See,
So
so
can we use also NM upon capital N formula also here, or it's not applicable here?
I think it's applicable.
and okay, yeah. Let's just complete this one. Then see, if you solve it, you will get something 1250, and it is for only one phone, right? Like xi. So in general, you need for all the 20 phones. And by property of expectation, you can do it, right? So it's nothing but 20 times this. I think it's 25,000 something.
Okay, sir.
And someone is saying nm by nm over n, right? This formula. I think it would be nm over.
For not defective, we can calculate like how many mobiles are not defective, and then we can just multiply with 2,500.
No, I don't think it will work. See, hypergeometric. You can't use it this question, I think. Read the statement again. There are 1,000 mobile phones, okay. See, hypergeometric, yeah, it can only tell you about the
It will tell me about like how many mobiles are non-defective and how many mobiles are defective.
the expected number of.
Yeah, expected number. Then we can multiply with the profits and losses. Then we can get the net profit, right?
Okay, once you're saying you get that. No, I don't think it works that way. It won't work. You can try,
That is the wrong
but
process.
I think it won't work because the calculation behind that nm over n is something which takes some different values for in account for random variable. So you can try that approach, get the answer, but I think that might not work in this case because hypergeometric is used when we are drawing something without replacement, and we have to find that a particular number of objects belong to a category, right?
Actually, I'm unable to understand what means exactly hypergeometric variable.
Yeah, then what is it?
Like
So
random variable, we define random variable. In the similar way, what it actually means, I'm not able to understand.
okay, so there is popular example of this pool, or you can say lake, okay, something, right? And within that
Okay.
there are two types of fish. Fish of type A and fish of type B, right? So let's suppose in total there are 100 fishes, and type A ones are, let's say, 20, and this one is 80, right? Now you have to catch 10 fish in total. Right. So what happens is you first, you got a fish, then after that from the remaining 99 you got another fish, and so on and so forth. You get the
Yes.
10 fishes, right?
Yes.
So here if you see the total number of fishes we have is 100, right? And I'm interested in, let's say, type A fish. This is my objective of interest, right? So if I am drawing 10 fishes, right, in total, then what is the probability? You have to find the probability, right, of that, how many type A fishes you have caught. This X represents the number of type A fishes you have caught. So for such things, we use hypergeometric distribution. Okay, so it's something like
But from this equation, how would we say exactly how many type A we got?
okay, see, if you have to find the probability of type A fish, right? Let's say you have to find for 5, right? So out of 20, you must catch 5 fishes of type A.
Why? Why 5?
I need 5 of type A, right?
Okay, we need 5. Okay, fine.
So out of this 20, I need 5.
Into
In total,
80C5. 80C5 again.
And total number of ways to
Divided by
catch.
100C10.
Yeah, that's your hypergeometric distribution.
But this is nothing but simple probability only, right? What
Yeah.
we do.
Yeah, simple probabilities are given different names, you will see.
So instead of using that nm by n, we can approach like this also.
No, this is the probability. If you find the expectation of this variable, it is nothing but x10. It comes out to be nm over n. Okay. That's the calculation of this.
In that question also there are total 10 and we have 2 type of mobiles. That is defective and
I
non-defective.
think it can work. As
It
she's
can
saying,
work.
I'm
it worked.
getting
I
the
just
same
calculated.
answer.
Okay.
Yeah,
They
it's
work with
coming.
hypergeometry.
Okay, see,
Yeah, we
there
can
are
do it.
1,000 mobiles in total, right? And defective are 100. No, defective are remaining 900, right? Okay, so you are saying first we compute the expected number of defective, right?
Yes.
Okay, it would be n. Okay, what is over? N will be 100, right?
No, N would be 20.
20.
We want 20 mobiles.
Okay,
Yeah,
M
we're
is
taking
100, right?
20.
Yeah.
Yes.
For defective, it's 900.
No, it's this way
No,
only.
okay, sorry, 100.
No, it's right. It's
This
Okay.
this is right.
Okay. So
By
generally
1000.
I don't use this formula. Okay, so this is the N, the number of defectives. This is the number of
No, it's the
Oh,
other
no,
way
you're
around. The other way around.
it's other way, right?
M and N.
Yes.
M is
And here's
100,
number of defective.
N is 20, and
And
divided by
capital N is
1000.
1000.
Okay, so N is
Divided by
number of
1000.
objects we are drawing, right?
Yes.
20.
Yes,
20.
Yes, number. Yes.
Okay. Upon we have
1000.
1,000 in total, right?
Yes.
Yes.
So in total there will be, I think it's 2.
Yes.
Okay, so we have 2 defectives. So
Yes.
it means 18 non-defective, right?
Yes.
And 2
Yes.
defective. So you're saying you will get minus 10,000 for them.
Yes.
And
18 into 2500.
18.
Okay.
Yes, yes.
Yes. And we get 25,000.
Same answer.
Is it working?
Yeah,
Yes.
yeah, same answer.
Okay, then you can approach like that. Okay, great. Yeah. So hypergeometric, see, if you remember this formula in quizzes or in, I think in many questions, it will help you from very tedious calculations.
Even earlier weeks, I think it would simplify our life because
Yeah.
we're using this a lot.
Yeah. So if you have to find expectation, this formula is generally used a lot.
If we forgot the formula, can we directly do Ex equals to sigma of xi into P of x equal to xi? Can you show how to use?
Yeah, you can do that, but that would be very lengthy. Like here, number of defectives can take value 0, 1, 2, so on up to 10, right?
Okay.
And then you have to compute probability for each of them
It will be
and
lengthy.
then multiply it. So
Okay.
there are maybe some question in quizzes where you will see that x takes value only till 3 or 4. Still in that case, computing probability and finding expectation is
Yeah, that's easy.
that's lengthy than using this formula directly.
Okay.
So if you remember this formula, it will, yeah, major problem is you should be able to identify. that it's
Actually,
hypergeometric.
that the application part comes to the problem where we have to apply correctly.
Yeah. So for now, it's only hypergeometric, but you'll see, I think, more distributions in week 11 and 12. So then you should be able to identify which one is it. Okay.
Because I'm facing this problem. Sometimes I'm using tree method, sometimes formula is needed. So first I'm approaching, I'm quitting, I'm wasting time, and again I'm switching to the another method.
No, just stick to one method and see what's going on over there.
The decision is the main thing, which method we should approach.
Yeah, if you try all the methods over here, then I think it will be more clear in quizzes like which method to approach.
Okay.
Okay. Any other question, Edna?
So I have a doubt in week 8's question 11.
Week 8. Okay.
Yes,
Any
sir,
questions
great.
from week 10 for now before we move to the
Sir,
Okay,
Yeah.
sir.
just want to get some conceptual clarity.
Okay.
As we say that expected value as a weighted average. So can we relate it to the central tendency measure with
Yeah,
mean?
it is mean. Expectation is nothing but the mean.
It's a mu, it's mentioned in the video, mu.
Yeah, it's the mean only.
That means
The
all
same symbol
the
for
formulas of
population mean. Same symbol as population mean, mu.
All the same thing.
that means the formula that we have derived in a case of central tendency, all those formulas are also applicable in case of this expected mean also.
Yeah, if you know the distribution, see, sometimes calculating expectation mean like that is very time taking, right? You know the observations, you take their averages, and here what we do is we assume that each one of them is equally likely to occur whenever we do that. So in that cases, the things just get cancelled out. Okay, let's suppose if you are rolling a die, right? Your sample space would be 1, 2, 3, 4, 5, or 6, right?
Yes, sir.
So if I assume the fair die means each one has the same probability. So if you find the expected value, let X be the outcome of a die, roll of a die. So it would be nothing but 1 times 1 by 6 plus 2 times 1 by 6. Right? So it's, in general, it's nothing but this thing. Just the arithmetic mean of these 6 digits. So whenever the outcomes are equally likely, we can simply compute the means. But in case the outcomes are not equally likely, let's say 1 has a probability of 1 by 4, 2 has 1 by 8. In that cases, you need to assign the respective probability. In that case, it would be weighted mean, not simple arithmetic mean.
Okay, sir.
So for now, whatever we were doing, we were assume everything to be equally likely. But from now onwards, it won't be equally likely.
Sir, one more doubt. What is the practical or interpretation of Bernoulli's random variable?
Bernoulli random variable. See, Bernoulli random variable, it may not be much used by you much in the real life examples, but the distributions we derive from Bernoulli are used mostly. The binomial which you will study in week 11, then Poisson distribution you will study it in stats 2, then you have geometric. See, Bernoulli is a base for all the distributions, and you will study most of this distribution in stats 2 for now. So what Bernoulli said is, suppose you are doing an experiment, right? You are, let's say, performing experiment, let's say tossing a coin. Right? This is your experiment, and you want head to appear. Okay? So for you, getting a head is some kind of success. Right? If you wish head to appear, so if you get the head, it's a success for you. If you didn't get the heads, you get the tails, it's kind of a failure for you. Right? So Bernoulli just assigned the probability, let's say the P with the probability of your success. Then for the failure, it would be 1 minus P.
Sir, in short, can I conclude that if for an experiment, if there are 2 possibilities, then it is one kind of Bernoulli's random variable?
Yeah, but yeah, you can, but Bernoulli's special cases, it assign probability 1, it assign the value 1 to the success with probability P and 0 to the failure with probability 1 minus P.
Okay.
Okay, it means you got a success if you are getting 1. If you are getting 0, you may see some random variable -1 and 1 if you get success, failure. You can also consider them, but yeah, it's somewhat generalization is this only. Yes.
Sir, one activity question 10.5, question number 3. Maybe it's simple, but I could not crack it that.
Variance of number of tickets sold. Okay, it sold a profit 25 rupees. Okay, variance of profit obtained. Okay. Okay, so you have to find the variance of. Okay, no, you are given the variance of tickets sold, right?
Yes.
Variance of number of tickets sold is somewhat 25. Okay. So I can define a random variable x saying that which represent number of tickets sold, right? We can do it, right? So my variance of x is somewhat 25 given to me in the question. Now it is given that the profit on one ticket is of 25. So the profit, if I am selling X tickets, right? So my profit on X tickets will be 25 times X, right?
Yes, that's good.
So I can define a new random variable Y, which represent my profit. So in general, Y is nothing but 25 times X.
Yes.
And you have to find the variance of profit, which is Y. So it is nothing but variance of 25 times X. And you know by the property of variance, it would be this. It's again 25, I think. It's 25 cubed.
Actually, I was very close to the answer, but could not crack it.
Okay, see, that's what the properties of expectation and variance.
In fact, I have defined the profit variable also, but somehow I could not get the solution.
Okay, as you will get it. Like, just keeps on practicing the end of question, I think. Okay. Anything else?
Sir, one more.
Yeah.
Activity 10.6, question number 3.
Question number 3. Among the random variables. Okay, how did you approach this one?
Actually, I have considered, as stated in the question, X and Z are independent.
Yeah.
Then what I have done is that I have considered Y is equal to 2X. So my standard deviation will be 3X plus Z.
Yeah.
And then I tried out, but it is 7 square plus 3 square, something like that was there. I'm getting the answer like that.
First of all, whenever you standard deviation, convert it into variance. Don't go in the roots things.
Okay.
That's the best part of dealing with. So whenever you have to find this thing, right? So what I can do is I can find variance and then I will take its under root. That's how we will approach, right? The easiest way. So variance of X plus Y plus Z, right? And Y is nothing but 2X. But you able to do it till this step?
Actually, yes, because since they are independent, so your A button 3 something, yes, like that.
So it would be 3 squared variance of X plus variance of Z, right?
Yes, sir.
And variance of X is, I don't know, it's
2.
2 and it's 7, right?
7, yes.
So 18 plus 7, 25. So standard deviation will be like 5, right?
Yes, sir. Again, very much near to the solution.
calculation error, right?
Probably.
Yeah. Yeah. See, these properties of these are pretty simple, but yeah, don't ever deal with standard deviation. Always convert it to variance. You will get
Yeah.
stuck in the square roots.
One of the method I have tried, that is from the standard deviation to variation. I have tried this method also. I was very near, but just maybe some calculation mistake. That is why I was not getting it.
Okay. The calculation mistake, it will be everywhere. Okay, it's 5 only, I think. Yeah. Okay. Okay. Anything else in week 10? Yeah.
No, sir. Thank you very much.
सर वीक 10
Yeah.
से तो नहीं है पर कल मैम ने जो बता रहे थे ना जो कम्प्लीमेंट वाला, तो उसको थोड़ा सा वेन डायग्राम में बता देंगे प्लीज।
Which one? Which complement part?
सर 1 मिनट। सर जो एफ कम्प्लीमेंट है ना, ए इंटरसेक्शन एफ कम्प्लीमेंट, वो थोड़ा सा मुझे वेन डायग्राम में समझ नहीं आया था, जस्ट उसको थोड़ा वेन डायग्राम में बता दीजिए।
A intersection F complement. I couldn't recall the question. Did you know the question statement or something? Like in which concept ma'am did it?
This is not a question. This is that independent event was there. No? Yesterday ma'am was telling independent, and I will just tell. Just give me a second, please.
I think I can use the slides as well. Okay, so yeah, which concepts are you talking about? The independence.
Sir, that conditional probability was there. No? That E given that F intersection C. That one actually. I will just open that page exactly.
This one.
Actually, yes, there was F intersection F complement was there. No?
It's in the concept of independence, right? You were saying.
Actually, Venn diagram. Actually, I was using the Venn diagram, but I could not understand what exactly it represents in the Venn diagram itself. I will open the slide page. Do
you know the name of? Okay, just tell me the statement what you want. Okay, so you're saying it's something. What is the event?
Yes, sir.
What is the event to represent in Venn diagram? Like F. Okay. You're saying intersection something complement or something, right?
Yeah, like we are taking, let us say there is two events, event E and event F. So
Okay.
E intersection F is clear, that the middle portion, and
Okay.
F complement. When you're saying E intersection F complement, what area it represents in the Venn diagram?
Okay, E intersection F complement. Okay. This is our, let's say, complete sample space. Okay? And let the two events be. So this is the event E and this is the event F, right?
Yes.
Okay. So what is your event E? E intersection F complement means the part common in between the two, right? The common
Yes.
area.
Yes, sir.
So area of E is this, right?
Yes.
And the area of F complement is everything outside F. Right? So now if you notice that the common area is only this region, the common between purple and green, right? So that's E intersection F complement.
Okay, sir. Okay, sir. I got it. Thank you very much, sir.
Okay, it's Mananjan, you were asking a doubt.
Yes, sir. I was asking doubt about question 11 of graded assignment week 8. Sir, I saw the solution, but solution was pretty straightforward equations, so I got confused. How come these equations came into play?
Okay, week 8, question 11, right?
So it is a question about rainy day and its implication that it would be a heavy traffic on the roads or not, and
Yeah.
then they ask if these two conditions satisfy, what is the probability that students would be late to the school?
Okay, so for such questions, the only what was law of total probability was used. Okay, let's see. Okay, so first of all, there are three possibilities, right? One is of rain, right? One is of heavy traffic, and
Yes,
one
sir.
is he was late for school.
Yes, sir.
So I'm defining these three events.
Sure. Okay, sir.
Now it is given to me that it rained 1/3 of the days. So probability of rain is 1/3, right?
Okay,
And
sir.
probability of not being rain is 2/3. So next thing given to us is that the probability that there will be heavy traffic on a rainy day. It means I am know that this is a rainy day, then the
Yes.
probability of heavy traffic is 0.5, right?
Okay, sir.
And on a non-rainy day, it's 0.25. This much information is given in the first two lines of the question, right?
Yes, sir.
Next thing is given to is that if it rains and there is heavy traffic, okay, so there is raining and there is heavy traffic, and means intersection, right?
Okay, sir.
Then the probability student arriving late to school is something 0.5, right? And if it is a clear day, okay, it is a clear day, and there is no traffic. No traffic. It is clear day and there is no traffic. Then the probability of him being late is reduced by 3/8. So it's 0.5 minus 3/8, right?
Okay, sir.
Okay. And in other situations, the probability of him reaching late to school is 0.25. Okay. In other situations.
Sir, so in other situations, it also captures the probability that it could be a rainy day and non-heavy traffic, and
Yeah.
can it also be the probability that it is a rainy day and it's it's not a rainy day and there is heavy traffic?
Yeah. These two things will also be covered.
Okay, sir.
That's what other
This statement was a little confusing because it wasn't. It should have probably said in each of the other situations. In other situations, it felt like all other probabilities to 0.5.
No, it's mentioned in other possible situations.
Yeah, so other
possible
possible situations could be the sum of the
No,
probability
it's
of
not
all
the
of
sum.
them.
It's
Well,
for
that's
each
not.
situation.
Yeah, because it's not saying in each of the other possible situations.
I think it's meant the same. Okay, we will edit it further. But yeah, it still meant the same. Okay. Yeah, we will make it in each. Right? In each of the situation, it's 0.25. If a randomly selected day, okay, the part you have to find. On a randomly selected day, student arrives late to school. So you're given that he arrives late to school. you have to find the probability that it rained that day, right? That's what you have to find. So in general, if you use the formula for conditional probability, it would be R intersection L over probability of L, right? Is it clear till this step?
Yes, sir.
Okay. So now to find probability of L and R intersection L, you have to use the what we say, law of total probabilities. Okay.
Okay,
So
sir.
yeah, so I'm erase shall okay, I think this will be used. Okay, so first let's think we can work in this area. Yeah. We have to find the probability of him being late, right? So what all are the possible scenarios? He can be late when there is rain and when there is heavy traffic, right? If you consider, okay, let's consider this Venn diagram. Okay, I am making 4 partitions. Okay. The first region is it rained and there is heavy traffic.
Sir, this kind of problem came in the weekly graded assignments, right?
Yeah, it's the week 8 question 11
Okay.
grade exam. Okay,
It is the same one. I joined late, sorry.
okay. See, R intersection, this is one of the possibility that can happen. No rain, no heavy traffic. No rain and heavy traffic. Rain and no heavy traffic. You see, all these 4 events are mutually exclusive.
Yes, sir.
They all are disjoint. So, and this is, let's say, some event of being late. This is event L. So,
Okay, sir.
L is nothing but the intersection of all of them, right? L intersection R intersection H. Then L intersection R complement intersection H complement, right? Then this thing. And then the last. There is no other possibility of making another partition, right? That's the only 4 possibilities happening.
Yes, sir.
Intersection R, intersection H complement. So you can compute probability of R. You can find like each of them by using the multiplication rule. You know these things, right?
Yes, sir. Yes, sir. By using multiplication rule. Okay,
Similarly, one more thing you need to find is, I think, R intersection L, right? So for R intersection L, again consider the Venn diagram. What all are the possibilities? We know that it's raining, late for school. Other thing left is that heavy traffic, right? So
yes, sir.
either heavy traffic or not heavy traffic. Consider this event sum. This event is, let's say, R intersection L. So probability of R intersection L will be either it rains or it didn't rain, right? Again using multiplication rule, or you have already computed it over here. This one and this one, right? So you
Okay,
got
sir.
your numerator denominator. You can find the probability. Right? Is this clear or not?
Yes, sir. It's a bit more tedious, but yeah, I'm getting the solution.
Yeah, you just have to use law of total probability 2 times. It's nothing else.
Okay, sir. So we first need to calculate some events and dependent events, and
Yeah, and see, don't get confused by this intersection. Okay, let's suppose the thing you have to find probability of A given A union B. Let's say, okay. Consider this A union B as C. It would be A given C, right?
yes, sir.
Simply use the conditional probability formula, A intersection C by probability of C. Now plug in the values. It's A intersection A union B,
Yes, sir.
and C is A union B. So if you Now for the above part, you can draw the Venn diagram. This is A, this is B. So A is this much part, right?
Yes, sir.
And A union B is
Is
this
whole.
much part.
Yes, sir.
So the intersection would be
A.
A. So it's nothing but probability of A log. Right. So don't get confused by whether it's union here, intersection over here. Just simply apply the formula, you will get it. Some easy way.
Okay, sir.
Okay, yeah. Anything else?
Sir, there is also a question on question 4 of in which we discuss an item produced by three factories A, B, and C.
Yeah.
Yes, sir. I had these were the two painstakingly difficult questions I faced.
Produce. Okay. No, this problem I think ma'am also discussed yesterday, right?
Okay, sir.
Yes. So it's something that three units are there are three manufacturing units which are producing, right? A, B, and C, right?
Yes, sir.
And let's say this is the event of defective. You have to find probability of that the selected item is defective. So either it could come from A,
Yes, sir.
or it could come from B, or it could come from C. Now you can simply use the multiplication rule to solve these intersections.
Excuse me, sir.
Yes.
Sir, in this particular question, it is given that A produces around 4 times more than B, and B and C produces equal amounts. So, sir, so will it affect the probabilities?
Yeah. Let's say let B produces X items. Okay.
Okay, sir.
And B and C produces same, right?
Yes, sir.
And A produces 4 times the B, which
So
means
it
4x
produces
items.
4x items.
In total, there are 6x items, right?
Yes, sir.
Out of which 4x belongs to A, X belongs to B, and X belongs to C, right?
Yes, sir.
So what is the probability that selected item is from factory A? It's
4x by 6x.
2 by 3, right? Similarly for B, it's X by 6x. And same for C. So these are the probability getting affected, A, B, and C. These probabilities are given to you in the question itself. Right?
Yes, sir. It's 10% and 7%.
Yeah. You can simply plug in and find the probability of defective.
Okay, sir. Also, I got confused in between the effect of items produced by particular factory in calculating.
Yeah, that's simple, just simple mathematics, simple algebra.
Okay, sir.
Okay, yeah. Anything else?
Sir, in the chat box, the first question.
The chat box is filled. Can you tell me the question? In the graded assignment?
Graded assignment 7-1. I have posted in the chat box first comment.
Graded assignment 7. This one,
This
right?
one, sir. This one I yesterday posted in discussion forum. So you told me to give the approach. Yeah.
Okay, we'll check it. Okay, so yeah, in general, solve this. See.
So my sir, can I say my approach first? Then you.
Yeah.
So like so my approach is there are total 11 boys and 2 girls, and 4 boys has to be in between 2 girls. So we can group them like 4 boys and 2 girls as one person.
We can group them as one.
Yeah. So right now there are 8 person, 7 boys and 1 that group.
Oh,
so that can be arranged in factorial 8. And 4 boys can be choose from the 11C4 factorial 8 into 11C4.
8 factorial. Okay, you are arranging this complete group.
Yeah.
And 7 others. Okay. Yeah.
Yeah. Factorial 8 into 11C4 because we can choose 4 boys.
Yeah, it
From
would be
11.
something like that. We first choose 4 boys to fix in between, right?
Yes.
Then make a group.
Yeah.
Then
Into
arrange them.
factorial 8.
And then arrange them in factorial ways. Yeah.
Into factorial 4.
Because we can interchange them.
Yes. Into 2 because
Into
2 girls
these two
also.
can interchange.
Yes.
Yeah.
And this is okay, but sir, I could not get how to calculate the denominator, like the sample space. This is the possibility that they can arrange between themselves for that condition. But what will be the below part, like
So it's
sample?
13 factorial. If you're doing like that, you can arrange all the 13.
Yes, sir, I did the same, sir. So is it right way or?
Yeah, it's the right way.
Okay, actually in the solution set, the process was something different.
Yeah, there are different approaches. Your
Yes,
approach is
yes.
also correct. If you simplify it, you will get the answer. It's not an issue.
Okay, sir. Sir, that's for okay, but in 7, like in 7 and 8, what I most most difficult for me is that how to choose and how to calculate the denominator part. I am able to get the result for the upper part, the event part that I can calculate, but the lower part, it's like very much problematic for me in some cases.
No, it's same. Whatever you are doing in the numerator, the same thing. See, in numerator you are arranging them, right?
Yeah, numerator means the total sample space below. Sorry, sir, denominator. Sorry.
Yeah, in the numerator, in this thing, you are just arranging them.
This is fine, sir. This is fine. Denominator part is like difficult.
In general, you are arranging all those 13 peoples, right? In some such that some specific condition like this is satisfied, right?
Yes.
If this condition has not been here, then in how many ways you can arrange 13 people?
In 13 factorial.
Yeah, that's what it is. Whatever you are doing in the numerator, just remove the conditions and plug in the denominator.
Okay, so sometimes we generally choose from the total sample space, then the denominator part get like smaller. Sometimes we do.
See, if there are, let's say, 10 objects, right?
Yeah.
And okay, and we have two, let's say, let's say there are 10 people, of which 5 girls and 5 boys are there, right?
Right.
And let's say we have to select 3 girls and 2 boys. So numerator will be, I select 3 girls out of 5 and 2 boys out of 5, right?
Okay, yeah.
But I'm doing, in general, I am selecting peoples, right?
Yeah.
Selecting 5 people in total out of 10. With some specific condition that 3 should be girl and 2 should be boys. Now, if I remove this condition of 3 girls and 2 boys, in how many ways can I select 5 people from this 10?
10 C5.
Yeah, that's the denominator, right? Just remove the condition and plug in.
Okay, sir.
Okay, anything else? Anyone else? Yeah. Let's see, 3 raised and yeah, Protiti Banerjee, you have any doubt?
The activity question 6.2, question number 3 and 4.
Okay, activity 6.2. Okay. Question number
3 and 4. Sir, I'm confused when I have to use n-1 factorial or n-1 factorial by 2.
Okay, you know, whenever there is circular permutation, we use n-1 factorial, right?
Yeah.
Okay. Now, what happens is when you arrange the beads of necklace, right? Or anti-clockwise and clockwise become same because beads are identical in some sense, right? It doesn't matter if I count them clockwise or if I see them anti-clockwise, it's the same.
Yes.
So in cases where clockwise and anti-clockwise are same, we divide it by 2 to remove those duplicate cases.
Okay.
So in general, if you see, let's suppose there are three objects, A, B, and C. Okay? If I had to arrange them in linear, we have the start point, we have this end point, right? And I can arrange them in 3 factorial ways, simply. But when I move to circle, what happens is we don't have any start point and end point.
Yeah.
Okay. So what happens is, these are the, let's say, 3 seats. So let's say A is here, B is here, C is here, A, B, C, A, B, C. So now see, if you look at it closely, it's A, B, C.
Yes.
It's again A, B, C. And it's again A, B, C. Right? So these three being looking different, they are same cases. Right? So that's the one case you have for now. If you look at the other three possible arrangements, because in total there are 6, right? In total there are only 6.
Yeah.
So these three are same, one case. Now another possibility is, okay, let's these 3 seats be here. Okay, now A here, C here, and B here. C, B, C, B. Now again, if you look at it, it's ACB over here.
Yes.
ACB and ACB. So these three are also same. So for 3 objects in circular permutation, we only have 2 possibilities, right? Which is true, 3 minus 1 factorial 2, right?
Yes.
Now, if I'm saying my clockwise and anti-clockwise are same, okay, so what it matters is, if I either count it clockwise or anti-clockwise, if they are coming same, they will be the same case. Like here, if I go anti-clockwise, it would read ABC. It would again read ABC, ABC. You see, my number of cases become half now. Only one possibilities. So that's what it, when clockwise and anti-clockwise are same, it's divided by 2.
Okay. Got it, sir.
Okay. Anything else? Anyone?
Sir, weekly tutorial 9, the first one, in the uranium problem, it was, can you open that? So I was just wondering if it was, I mean, usually because the C was 1, it doesn't matter anyways, but usually it will be C by 2 whole power K, no?
The probability of survival of atom after K life is, the equation is given to you. You are not computing.
Not the equation, but when we find the half-life. Sorry, not C. I'm sorry. N. The half-life is N by 2 whole power K, no? When
No. It's N by 2, then N by 4, N by 8, something like that. Okay. See, what happens is, suppose you have.
Okay. Understood. Sorry.
It's half, right? It's half. So yeah. This is N N by 2, N by 4, then again half it by 8, N by 16.
Yeah.
Something like that.
Okay, got it. Sorry. Got
it. Yeah. Anyone, anything else?
Hi, sir. Good morning.
Yeah, good morning.
Sir, yesterday the mock test, the question were there, but today I'm not able to remember the question exactly because it is not available.
Yeah, it will be made available.
Okay. So can we discuss now? Like there was one question regarding the arrangement. I mean, how many distinct words can be made from choosing 5 letters out of by at least choosing 2 out of 5.
Okay. At least 2 out of 5. Okay.
So the question was like that. I don't remember exactly, but if anyone remembers, they can also tell.
See, mock, we have a separate session. Till then, we want you to try it all by yourself only. We
Okay,
will
no,
release the solution only on Fridays.
no, it was the solution was already shared yesterday. Like
To
not
get the
solution, the
answer to
answer.
be 320.
Yeah.
Yeah, that is the answer.
Yeah,
Yeah,
only
answer
answers
was,
are shared, right? Not the solutions.
yeah, solution was not given, but we
Yeah.
got to see the answer. Like
Yeah,
320.
answer you can see. Yeah. So you know the question, the answer. I think you can still try it. Right?
There are 0 to 9 numbers given and a number to be found in between
No,
999
that is
to
different.
6,000.
That is
Is
different.
this question?
No, that is different. Like the question was like how many distinct words can be formed by selecting at least 2 out of 5 letters, which can be randomly selected, and repetition is not allowed. That was the question, I guess. The answer I got was 320 into 26, choose 5. But that came
But
out to
it is
be.
only 320. I got the answer 320. I don't have the answers with me. I wrote it down on my book though.
I think
couldn't
it's
submit it.
something like you have to make at least 2-letter words, right?
Yes.
It was
So
like
first you
Somebody
make
put the
2-letter
question in the
words.
chat box, sir.
First you make the 2-letter word, right?
Yes.
And how many ways you can make it, right?
Yeah.
Then you make the 3-letter words. If you make 4-letter word, it's still satisfying my at least 2-letter word criteria, right? And then you have to make the 5-letter words.
Yeah, this summation of this comes to be 320.
Yeah.
But then again, we can also choose 5 letters from 26 total letters.
No, you are given 5 distinct letters. Out of those 5 distinct letters, you just have to make something like that. You are not going to complete 26 alphabets.
Oh, okay. So that was the only additional multiplication I did.
Yeah. Yes. Syllabus of quiz 2 is complete weekend. Conditional base everything. Okay. Anything else?
Excuse me, sir.
Yeah.
Sir, are quizzes mock tests of yesterday's session available? Because I think these are of quiz 1, mock test 1.
Yeah, it will be made available. And today you will be having 3 to 7 also.
Okay, sir.
Okay, anything else?
Sir, I actually have one. I need one clarity in concept in week 7 tutorial. Can you go please? Week 7
Yeah.
tutorial. One PDF was available.
Okay,
Yeah, that one.
Yeah. Let's. Yeah.
Yeah, please see the question 2 and question 4. In question 2, it is like it is said that in a nut bolt manufacturer you can see. So the approach they did it. They first select the numbers 10 pairs out of 200, and then they did the probability.
Randomly select 10 pairs.
Yeah, out of 200. So the sample space will be 200 C10.
Yeah.
And the above part there will be like what is the probability exactly? 3 pairs out of 10 is, and okay, so 10 C3 into
10 by 10 C3. 8 are defective already. So it's 8 C3.
Okay, sorry. Yes, 8 C3 into we have to consider also for the non-defective.
Yeah, 7 non-defective should be there, right?
Yes. So here we are doing like both in the numerator, we are doing the multiplication, having the below part same, but in 4, question number 4, 30,000 student joins IITM online degree. Here what they are doing, they are like 1,000 by 30,000 by 30,000 into 200 like 29,000 in by 30, but 30,000. So they're splitting these two.
One minute. Let's look at. Okay, so in total there are 30,000 students, right?
Yeah.
Out of those, 1,000 are given
Feedback form.
and 29,000 are not given, right?
Yes, sir.
Okay, so what you're saying we should do in it? Or what
Yeah.
they happen? Yeah.
I think that we should do like the previous one, 1,000 into 29,000 by 30,000. But here in that case, obviously probability will be more than 1, so it is not possible. But I want to understand the logic.
The question is, the Mary got the feedback and Asad didn't. Okay, that's fine. See, if you look at it, you know that out of 30,000, thousands are given and 29,000 are not given, right?
Right.
So what is the probability that someone will get the feedback form? It's
1,000 by 30,000.
What is the probability that someone will not get the feedback form?
29,000 by 30,000.
30,000, right? So what is we have to find the probability that Mary got the feedback form, right?
Yes, sir.
Feedback form. So it's 1,000 by 30,000, right?
Right, sir.
And probability that Sir didn't get it.
29,000 by 30,000.
30,000, right? And since we are doing it randomly, so it means these two events are independent as well. Whenever we're doing something randomly.
Yes, yes.
So Mary got the feedback and Asad didn't. So, right?
Yes, sir.
O squared. The independence rule is used over here.
Okay.
Independence and multiplication rule. You can say.
Okay.
Okay. Anything else? Anyone?
Sir, I have a doubt in week 10, lecture number 2.
Week 10, lecture 2. This?
Yes, sir.
Okay.
Time step 4 minutes 30 seconds.
Oh, 4 minutes. This one?
Yes, sir. Here, ma'am calculated the average winning as minus 0.09. How they compute that value, sir?
Average winning is nothing but the expectation or something, right? Or so it's something, 1 times 0.16 minus 2 times 0.10, 3 times 0.16, 4 times, right? This is the thing we are doing over here, right? So it's same as, let's say, let's consider it with 3 outcomes. Okay. So see, these are the 3 possible outcomes for any experiment. Okay. And the chances of getting it, let's say it's 0.16 for it, and it's 0.50 for it, and it's 0.3 for it. Okay. So the average, see, when suppose this thing is not given to you, and if I ask you to find the average of these 3, it would be simply 1 plus 2 plus 3 over 3, right?
Yes, sir.
But in such cases, we assume that each one is equally likely to happen. But here, if you see that 2 has higher chance of happening than 3, and then 1 has a lowest chance of happening. So what happens is, while computing the average, we also assign them some weights, which is nothing but their chances of happening. So 1 has 0.16 chance of happening, 2 has 0.50 chance of happening, and 3 has 0.34 chance of happening. But in the case if they all had equal chance, let's say 1, 2, 3, each has equal chance means each one has 1 by 3, right? If you compute its average, it would be 1 times 1 by 3 plus 2 times 1 by 3, 3 times 1 by 3. It's nothing but the same.
Okay, sir.
So whenever the chances are equal, you can say that simple average is the same. But when chances of happening of each of them is different, you assign that these. So it become a bit different way of computing average. It's also called expectation.
Okay, sir, got it.
Okay, anything else? Or shall we close for today?
So it
Yeah.
will be very helpful if you can explain a little about Base Theorem, just a brush up.
Base theorem. Okay. I think ma'am also did it study that. Base theorem is.
Yes, sir.
Okay.
I was able to attend a meeting yesterday due to some domestic chores.
Let's consider there are some. This is my complete sample space. Complete sample space,
Okay.
and you know each event is nothing but a subset of sample space, right? So let's suppose these are my 4 events: E1, E2, E3, and E4. Right? And I'm assuming that all my E1, E2, E4 are disjoint, or one can say mutually exclusive. Okay. And within that, let's suppose this is my another event, let's say event F, right? So now 3 cases arises, 3 things which you can compute from here. One is if E2 is occurring, if E2 occurred, let's say, then probability of F occurring, right? Second is probability of F occurring only. Third is F has occurred, then probability of, let's say, any of you can choose. I'm choosing, let's say, E2 occurring. Okay. Now we will go one by one in each of the case. If you notice over here, if E2 occurred, then the probability of us occurring, right? So if you look at over here closely, it's something given to where this event has occurred, right? This is your new sample space now. E2 has occurred. So you have to find the F given E2, which you simply do by conditional probability, right? You find this intersection, and generally you know this E2 in most of the cases, right? So you get this probability.
Okay, sir.
Probability of F happening in this E2. Okay. So this is the conditional probability thing we do.
Okay, sir. I got it. Sir, in question 12 of graded assignment 8, they use probability to calculate the number of shirts, a value of n. Can you look to it?
So first, please, this finish now.
This one is complete.
Yes, sir. Second and third portion.
Second and third portion, yeah.
Okay. See, this is the conditional probability, right? Something.
Yes, sir.
Next thing is probability of f occurring. It is nothing but law of total probability, right? You find intersection of it with all, E1, with E2, with E3, and with E4, right? The probability of f occurring is nothing but its intersection with everyone. So that's law of total probability. Next comes the Bayes theorem. Now Bayes theorem, see how it's a bit different from.
Sir, sorry for interruption, sir. यहाँ पे like if intersection E3, what will be the thing? Because if intersection complete thing will be the area, the second area, right? Which you hatched before. But if intersection E3, which one will become? Can you please identify these areas?
F intersection E3. F intersection E3 is this, right?
So the blue circle is F?
Yeah, blue circle is F.
So the second one is F or E2? Second one, the E1.
This is E2.
Okay.
Okay. So this is law of total probability. The last thing is, it is the Bayes theorem. What happens in Bayes is this event, this our event F, we know that this has occurred. This event is nothing but, you know, some disjoint unions of intersection with each of E1, E2, E3, and E4, right?
Yes, sir.
So we know that this event has now occurred. You have to find the probability of E2 occurring.
Yes, sir.
You can find of any, I'm assuming E2 to find this. So in general, you have to find this.
Yes,
which
sir.
again, by using same formula as conditional
E2
probability, you can compute. For probability of F, you need to use law of total probability, this one.
Okay.
Yeah.
And E2 intersection F will be the same.
Yeah, you have already computed it over.
Yeah.
So,
Sir,
yeah.
Can you mark, please, E2 given F, which one the space is? Like the pink colored one?
Okay, E2 given F, right?
Yeah.
E2 given F means this green area. This green area has occurred. This is my event
Inside
F.
the E2 box, right? Not total one. Inside the.
Yeah, given F. Given
Okay.
F means my new sample space is this green region.
Oh, yeah.
Within this region, what are the chances of this red region happening?
Right.
That's something. So whenever you have to find, you know, let's say these four are mutually exclusive events. Whenever you have to find, you know that one of them has occurred and you want to find the probability of this event F, you use conditional. When you want to find the complete probability of happening of F, you use law of total probability. When you know itself that this event F has occurred, and you have to find the probability that either E1 has occurred or any of it, I'm taking E2 over here, then you use Bayes theorem.
But sir, this red area which you have marked, that is also E2 intersection F, right?
Yeah, E2 intersection F. We compute
So
it.
actually, this is the main problem. I could not understand. Like, I can understand. I can also understand that formula, but I cannot conceptualize like what is the difference between A intersection B and A given B. Can you please explain through Venn diagram? I can the A intersection B is fine, but A given B, can we see in present, like in
see,
form
these
of Venn
two are
diagram?
my events, let's say A and B, right?
Yes.
Whenever, suppose I'm finding A given B,
right?
This given B this is my sample space complete, right?
Yes, sir. Yes, sir.
When I say given B, this is not my sample space anymore. My new sample space is this.
Which means B has already occurred.
Yeah, B has already occurred. This is my new sample space.
Okay.
B. Now within B, what are the chances of happening of A, right? This means B is your new sample space. You have to find chances of occurring of A. So your favorable region is this much
A
only.
intersection B, yes,
Right,
sir.
right.
Because this region is not in my sample space.
No, sir.
Okay.
So,
Okay, thank you,
so
sir. Thank
yeah,
you.
favorable is A intersection, right? And
C,
sample
yes, sir.
space is B.
P of B, yes, sir.
And also, yeah, all the properties, like, if this is my sample space complete, right? And this is some event A, probability of A complement is 1 minus probability of A.
Right, sir.
Yes, sir.
And, some other property, let's say there are two events A and B. Then you also know A union B is probability of A
A
plus
plus
probability of
B minus A intersection. Probability of A intersection.
okay,
Yes, sir.
and all other properties which you can think of. Okay. Now let's come to this given thing. Okay. I'm taking three events. Okay. Just to get it. These are my three events. Let's say. Okay. Now I'm saying this event has occurred. This event A has occurred. This is event B. This is C. So given A, whenever I say, it means this A is my new sample space, right?
Yes, sir.
It's A. So now you have to find. Okay. If you okay, probability of B complement given A, it will also satisfy this property because it is same as this, but my sample space has changed, so it will be still this.
This is 1 minus probability B given A, right?
Yeah.
Yeah.
If you have to find union of this B union C in this, right? B union C given A. So within my new sample space, I have to find B union C. It will still be the same. Probability of B in my new sample space, probability of C in my new sample space, minus B intersection C in my new sample space. So this given A just represent that you have a new sample space. All the properties will still be satisfied.
Yes, sir. So right now the new sample space is A, and we are considering all other event in terms of A.
Yeah, all these conditions, properties which you know for the sample space will be satisfied by this.
For new sample space A,
yeah,
right?
It will also be satisfied.
Okay. Thank you, sir.
Okay. So if you have to find this probability of B complement given A and you know probability of B given A, just simply use this property. Don't try to compute it. You can still do it, right? Is this clear?
Yes, sir. Completely clear, sir. Okay. So actually, I could not think in terms of Venn diagram that given conditional probability. That's why all problems actually arise.
So,
yes.
Probability of B intersection C given A, what will be the area?
Okay, I have to draw it more clearly for that. This is let's say A, this is let's say B, and this is let's say C, right? I'm saying that my event A has occurred.
Yes, sir.
Event A has occurred. So B intersection A, we have to find B intersection C, right? In my new sample space A. You see, this is the only region, right? In general, B intersection C is this complete region, but this much portion
within
is
given is A intersection B
my
intersection C only.
This is outside my sample space, so I have to work only with this.
Okay, sir.
Okay. Anything else? Anyone?
Yes, sir. In question number 12, the question was if we have question number.
In which question? Like which week? Which
week
assignment?
8 graded assignment.
Okay. Question number 12. Okay. This one, right?
Yes, sir.
So how did you approach for this?
Tried to use permutations and combinations to compute it, but at the end I didn't get the solutions because I was trying to compare them.
Okay, let's see. Okay, there are two shops, A and B, and there are two blood. Okay, one shop is selected at random. Okay, so a person can either go to shop A or shop B, right? And shop A has stock of n red t-shirts and two black, and B has the reverse, I think, two red and n black, right?
Yes, sir.
Okay, one of the shop is selected at random. At random, it means I can either select A or
Or
B.
B.
Both have same chances.
Yes, sir.
And I have purchased two shirts. Okay, if both the t-shirts are red. Okay.
Yes,
Uh,
it is
okay,
given,
let's
sir. Both t-shirts are red.
rectify. Both are red. Okay, and the probability it was purchased from shop A. Okay, it is given that both are red and it is purchased from shop A. It is given to us 6/7, right? This is the question statement.
Yes, sir.
Okay. Now using conditional probability or formula, you know this is how we can open it, simplify it, right?
Yes, sir.
So what is A intersection E? A intersection E is we got both red t-shirts from shop A,
Yes, sir.
right? So both red. So it means in the shop A, there are total n+2 t-shirts.
Yes, sir.
You are choosing two of them, right? And your favorable are
Red.
and C2, right?
Yes, sir.
Okay. And if you look at this both red t-shirt, right? The only possibility is either you go to shop A or shop B,
Okay, sir.
or this is my event, let's say, of getting both red t-shirts.
Yes, sir.
The probability of E would be nothing but A intersection E plus B intersection E, right? The law of
Sir,
total
I
probability.
was able to compute till here and get those values, but at the end, when I saw the solution, they were using Bayes theorem. Uh,
Yeah, we are using Base Theorem
yes, sir. No, so I
because
was
I
able to
just,
compute till here, but at last I got confused.
yeah, see, why we are using Base Theorem, these two are my mutually exclusive event, A and B, the complete partition of my sample space. I know that this event has occurred, which is the
Okay.
disjoint event of these two.
Okay, sir.
I have to
And we
find
have
that,
to find.
yeah. So
Sure.
remember, we covered those 3 points. So it's
Yes,
base.
sir.
So as soon as you compute this, you can simply plug in the values. Even if you don't know its base theorem, you can still find this value and plug it, right?
Yes, sir.
Yes,
If you're
sir.
not able to identify. So that's not a major issue. Okay.
And in A intersection E, we don't have to consider the probability of A half.
No,
Sir,
no. A intersection E means I in we are talking about only this region to happen, right? Out of these two radars are chosen.
Okay, so we don't have to bother about
Yeah,
probability of A.
yeah. If it has been B intersection E, it would be something 2C2, right?
and
Something.
yes, sir. And last, they use this particular probability to calculate
Um,
the value of n.
1 minute, 1 minute. I think we have to choose for A also. Intersection E. Yeah, you will have to choose for A also. Yes, that's a good point. That would be half.
Yeah.
Because first we choose A, then we go for two red. Yes.
Okay.
Okay.
Choose
Yeah, that would
B
be,
and then we go for that.
yeah, that would be half also. Yeah. Thanks for this. Yeah. Okay.
Yes, sir. And then they compare for this particular event. In the solution PDF,
Yeah.
E1 is an event of shop A selected, E2 is shop B selected,
Yeah,
and
I'm
then
just
they,
using A and B
yes
simply.
sir, and then they calculate of conditional probability that red shirt is having that red shirt is selected, so the probability that it is from shop A even, and then they use Base theorem. So they multiply by, in numerator they keep P
Hmm.
even multiplied by P E even.
Yeah,
So
this is the same thing. If I'm computing A intersection E, I can use that uh, multiplication rule. Yeah, that's why half is also over here. Right? Probability of A times E given A. Multiplication rule we are using for all this.
okay sir.
So Bayes theorem is nothing but just a bit different scenario used in the conditional probability.
So there are
Okay sir.
so many formulas in statistics, but I don't know why still I'm so shaky. I just feel I'll miss out on one thing or the other in solving these questions. Some aspect I'll miss. And I know it's all about practice, but still the confidence is not coming because every question is unique in itself. Very
Yeah,
tough.
graded assignment are designed that way that you get exposure to all the varieties you can ever see.
Completely different. Each question was different from the other. And despite knowing the concepts, despite knowing the formulas, it's really very tough. Statistics is scaring me because of that. But I know all the formulas, but I'm still not convinced I'll be able to solve the problem
Yeah,
or
nothing
interpret it
major in
correctly.
formula over here. It's all about the concept. Once you're clear with
Yeah.
concept, you simply go and get it right. Okay. Anything else? Anyone? Okay. Okay, I think we can close then, right?
Thank you, sir.
Okay. Thank you, everyone.
Thank you.
Thank you
Thank you
sir.
very much, sir. Thank you very much,
Thank you.
sir.
Hello, sir. Hello, am I audible? Hello.